pair of linear equation in two variables. Equation of the form ax plus by plus c is equal to 0, where a square plus b square is not equal to 0, is called linear equation in two variables x and y. Examples are: solution of such an equation is a pair of values x and y represented as, at which LHS of the equation becomes equal to RHS of the equation. Example: putting x is equal to 4 and y is equal to 2 in the equation, we get LHS equal to RHS. Thus, 4, 2 is the solution for equation 3x plus 4y is equal to 20. Similarly, putting x is equal to 0 and y is equal to 5, LHS becomes equal to RHS. Hence, 0, 5 is also a solution for 3x plus 4y is equal to 20. Plotting these solutions, that is 4, 2 and 0, 5, graph gives a straight line. Every solution of the equation is a point on the line representing it, and every point on the line representing a equation is a solution to the equation. Problem: the cost of pencil is twice the cost of eraser. The cost of 3 pencils and 4 erasers is rupees 20. Then what are the cost of pencil and eraser? Solution: using pair of linear equations in two variables. Let cost of pencil be variable x and cost of eraser be variable y. From given conditions, x is equal to 2y, since cost of pencil is twice the cost of eraser, and 3x plus 4y is equal to 20, since cost of 3 pencils and 4 erasers is rupees 20. The general form of pair of linear equations in two variables x and y is a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, where a1, b1, c1, a2, b2, c2 are real numbers, and the term a1 square plus b1 square is not equal to 0 signifies that a1 and b1 are not both 0. Also, a2 square plus b2 square is not equal to 0 signifies that a2 and b2 are not both 0. Both equations represent separate line, hence there are 3 possibilities with these lines. The two lines intersect at one point. Unique solution. The two lines did not intersect, that is, they are parallel. No solution. The two lines are coincident, that is, infinitely many solutions. Case 1. The two lines intersect at one point. Unique solution. Table shows values of x and y. If we plot these two equations graphically, then we observe that each equation forms a straight line. There exists a point, that is, point of intersection, which is a solution to both equations. Case 2. The two lines did not intersect, that is, they are parallel. No solution. Equations are x plus 2y minus 4 is equal to 0, 2x plus 4y minus 12 is equal to 0. The graph for these equations will be as follows. Since these are parallel lines, hence there will be no solution. Case 3. The two lines are coincident, that is, infinitely many solutions. Equations are 2x plus 3y is equal to 9, 4x plus 6y is equal to 18, and the corresponding graph is this graph shows that the lines of each equations are coincident. Hence, these equations have infinitely many solutions. Graphical method of solution of pair of linear equations. Finding the solution of equations graphically. Case 1. Lines representing a pair of linear equations intersect at a point. In this case, lines intersect at a point. Hence, this is the only solution for both linear equations. Such pair of linear equations for which there exists a unique solution is called as consistent pair of linear equations. Case 1. Lines representing a pair of linear equations intersect at a point. In this case, point 4, 2 is the point of intersection. It is a solution for both the equations. Case 2. Lines representing linear equations are parallel. In this case, there is no point of intersection. Hence, there is no solution. Such pair of linear equations for which there is no solution is called as inconsistent pair of linear equations. Case 2. Lines representing linear equations are parallel. In this case, there is no point of intersection. Hence, there is no solution. Case 3. Lines representing pair of linear equations coincide. In this case, lines coincides, that is, overlaps. Hence, there exist infinitely many solutions. Such pair of linear equations which has infinitely many solutions is called as dependent pair of linear equations. Case 3. Lines representing pair of linear equations coincide. In this case, lines coincides, hence there exist infinitely many solutions. Checking consistency for pair of linear equations. We can easily check for consistency by comparing the values of a1 divided by a2, b1 divided by b2 and c1 divided by c2. Following table shows the results. For example, x plus 2y minus 4 is equal to 0. 2x plus 4y minus 12 is equal to 0. Here, a1 is equal to 1, b1 is equal to 2, c1 is equal to minus 4, and a2 is equal to 2, b2 is equal to 4, c2 is equal to minus 12. Now, a1 divided by a2 is equal to 1 divided by 2. b1 divided by b2 is equal to 1 divided by 2. c1 divided by c2 is equal to minus 4 divided by minus 12, which is equal to 1 divided by 3. Comparing with the table, we get a1 divided by a2 is equal to b1 divided by b2 is not equal to c1 divided by c2. That is, these equations form parallel lines, hence no solution. That is, the pair of equations are inconsistent. Algebraic method of solving the pair of linear equations. Substitution method. Graphical method, however, not suitable when the solution of pair of linear equations may have non-integer coordinates such as root 3 to root 7 or 1.27, 2.36, etc. Hence, we need to solve these equations by algebraic methods. Example. Let us understand this method by taking an example and solving it stepwise. Consider 7x minus 15y is equal to 2 and x plus 2y is equal to 3. Step 1. Find the value of one variable in the form of other variable. That is, equation x plus 2y is equal to 3 can be rearranged as x is equal to 3 minus 2y. Step 2. Substitute this value in 7x minus 15y is equal to 2. We get y is equal to 19 by 29. This is the value of one variable. Step 3. With the value of one variable, calculate the value of other variable by substituting the obtained value in any of the equation. We get x is equal to 49 by 29. The solution for pair of linear equation in two variable is x is equal to 49 by 29, y is equal to 19 by 29. Checking the solution. Put the obtained value in any of the polynomial and then compare LHS and RHS. X plus 2y is equal to 3. Putting x is equal to 49 by 29 and y is equal to 19 by 29 and solving the equation, we get LHS equal to RHS. Hence, the solution is correct. Cases. Case 1. Unique solution. In substitution method, if we get the values of all variables, then it signifies that the pair of linear equations have unique solution. Consider 7x minus 15y is equal to 2 and x plus 2y is equal to 3. Having solution x is equal to 49 by 29 and y is equal to 19 by 29. Graph of unique solution will have intersecting lines. Case 2. Infinitely many solution. For such pair of linear equations in two variable, if we get true statement involving no variable, then equations have infinitely many solutions. Consider 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18. From 1 we get, put 3 in 2, we get 18 is equal to 18. The graph of infinitely many solution will have overlapping lines. Case 3. No solution. For such pair of linear equations in two variable, if we get false statement involving no variable, then equations have no solution. Consider x plus 2y minus 4 is equal to 0. 2x plus 4y minus 12 is equal to 0. From 1 we get, put 3 in 2, we get minus 4 is equal to 0. Graph of no solution will have parallel lines. Algebraic method of solving the pair of linear equations. Elimination method. Let us understand elimination method by solving a pair of linear equation. 9x minus 4y is equal to 2000. 7x minus 3y is equal to 2000. Step 1. Make coefficients of one of the variable numerically equal by multiplying one or both equations with suitable non-zero constant. Equation 1 and 2 are: multiply equation 1 by 3 and equation 2 by 4 to make the coefficients of y equal. Hence, we get 27x minus 12y is equal to 6000, which is equation 3. 28x minus 12y is equal to 8000, which is equation 4. Step 2. Coefficients of one of the variable in both equations is numerically equal. Hence, we can easily eliminate these variable with addition or subtraction. Equation 3 and 4 are: subtract equation 3 from equation 4 to eliminate y, because the coefficients of y are the same. Solving the equation, we get x is equal to 2000. Step 3. Substitute the value of one variable into one of the original equation to get value of other variable. We have x is equal to 2000. Substituting this value of x in 1 and solving the equation, we get y is equal to 4000. Cases. Case 1. Unique solution. If we get specific values, then the pair of linear equations have unique solution. That is, the values of variables. Case 2. Infinitely many solutions. If we get true statement involving no variable, then the pair of linear equations in two variable have infinitely many solutions. Case 3. No solution. If we get false statement involving no variable, then the pair of linear equations in two variable have no solution. Cross multiplication method. This method includes cross multiplication of terms. Steps to solve problem by cross multiplication method. Step 1. Rearrange the given linear equations in two variables as given below. a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. Step 2. Enter the values in the diagram below. Create following equation by cross multiplication of terms. Step 3. Find x and y. Example. Consider following pair of linear equations in two variables. 2x plus 4y minus 46 is equal to 0. 3x plus 5y minus 74 is equal to 0. Enter the values in diagram below. Putting all the values and solving the equation, we get x is equal to 8 and y is equal to 10.
Derivation of the formula. Consider following pair of linear equations in two variables, a1x plus b1y plus c1 equals 0, and a2x plus b2y plus c2 equals 0.
Step 1. Multiply equation 1 by b2 and equation 2 by b1 and solve the equation. We get equation 3 and 4. Step 2. Subtracting equation 4 from 3, we get x is equal to b1c2 minus b2c1 divided by a1b2 minus a2b1, which is equation 5, where a1b2 minus a2b1 is not equal to 0. Step 3. Substituting this value of x in 1 or 2, we get y is equal to c1a2 minus c2a1 divided by a1b2 minus a2b1, which is equation 6. Rearranging equation 5 and 6, we get equation 7 and 8. From equations 7 and 8, we get significance. When a1 by a2 is not equal to b1 by b2, then we get a unique solution. When a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then there are infinitely many solutions. When a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then there is no solution. Equations reducible to pair of linear equations in two variables. Equation of the form ax plus by plus c is equal to 0 is called linear equation. This method is used to find the solutions of equations which are not linear. Examples are 2 by x plus 3 by y is equal to 13. 5 by x minus 4 by y is equal to minus 2. These equations are not of the form ax plus by plus c is equal to 0. But with proper substitution, these equations can be made linear. Example: rearranging the equations, we get 2 into 1 by x plus 3 into 1 by y is equal to 13 as equation 1. 5 into 1 by x minus 4 into 1 by y is equal to minus 2 as equation 2. Put p is equal to 1 by x and q is equal to 1 by y in equation 1 and 2. We get 2p plus 3q is equal to 13 as equation 3. 5p minus 4q is equal to minus 2 as equation 4. After obtaining the values of p and q, we can easily find the values of variables x and y, as p is equal to 1 by x and q is equal to 1 by y. These are the pair of linear equations in two variables, and hence these can be solved by graphical method, substitution method, elimination method, cross multiplication method, etc. Thus, the pair of linear equations can be solved by any of the method.